we bumped that to 1,000. And maybe now a deterministic model gets 80% more effective. And I'm just making numbers up. But the indeterministic, or the cooperation model, gets 40% effective. Okay? Is that fair enough? Nobody's thrown up yet? All right. But now I'll say, let's jump up to 1 million servers, and let's just add this whole layer of complexity of now multiple infrastructures, things like maybe OpenStack, VMware, things that don't exist yet, network systems that are all over the fucking place. And so throw that whole dimension into it, and you got 1 million servers. I would argue that at some point, deterministic or obligation models, they're going to cross paths. And that at some point, you're going to see, and I'll just make up numbers. Let's say we get to 1 million and the complexity is ridiculous and the entropy is really high in terms of the disorder of how things can be managed, and they change so freaking fast that all of a sudden now an indeterministic model, a cooperation model becomes 70, 80% more effective, and a deterministic, fact-based, Newtonian way of thinking, is it making sense, becomes maybe 40 or 30% effective. And then turn it into 10 million. Right? And at some point it becomes almost arrogant to think that you can sit back as a human and control the way that you're going to manage these complex systems. Because guess what? When you fly a plane, there isn't one little guy sitting there or one little engine. It's a bunch of cooperative little autonomous agents trying to figure out how to work together. And actually, by the way, instead of the human being the guy who manages and decides how everything's going to look every day and every 15 minutes or every hour, the human is just another autonomous agent in the large picture of things. So I would say that in third generation, the winners are going to be systems that think like that. They think kind of autonomous, that are truly based on complex adaptive technology ideas. I would say there's some early examples. Promise theory is very promising, excuse the pun. CFengine 3 is an initial implementation of a problem that I think is going to take a long time to solve, and maybe we're not even there in my analogy earlier of maybe deterministic and obligation models are more effective as we sit today. I do believe that they won't be in the future. New Relic, I think, is an example. I don't play with this. Might be an example of embracing these type of complex adaptive systems. I had an interesting, one of the things that happens a lot is I get the opportunity, at these conferences to meet some really interesting people. So there's a gentleman called Pedro Cajani who is he's the head of the SRE group at Facebook. Some of you might work for Facebook. So every time I talk to him, I throw this idea out. Like, am I an idiot? Am I just like making these things up, or am I on course? And last time I was at Velocity last year, I asked him gave him my whole analogy of, aren't we going to get to a system a day where this is going to be too complex? He said, we already have that. We've built a complex adaptive, a CAS system that does remediation. That if we turned it off tomorrow, basically we'd have to hire 300 employees. Right? So, we're already there. All right, so last but not least is this idea of promise theory of what I promised, and I apologize if I did the head fake, but hopefully some of you have enjoyed this journey. So I'm going to tell you about promise theory, and so if I go back to why I was here, Mark Burgess asked me, a couple of years ago, hey, John, can you help me think this through? I like Mark a lot. I've gotten to know him really well. I don't even have a college degree, and I got a physics professor ask me questions. I mean, that works my ego pretty well. So I like hanging with him. I got to actually DevOps Day Rome. Actually, we got to spend the day walking around Rome all day on the day after the DevOps Day conference, and we just talked about life. We talked about promise theory. We talked a little bit about physics. We talked about DevOps. He's an awesome guy to hang out with. Anyway, so I decided to learn promise theory, and so I'm going to give you my version of the promise theory for dummies, and we'll try to tie this all back together to why I think it fits into DevOps, why I think it fits into this. So, by definition, this is what you get from the website. Promise theory is a model of voluntary cooperation between individual autonomous actors or agents who publish to one another in the form of promises. And if you do some of the research, there are, the CFengine 3 is a manifestation of promise theory for what most of us in this room know and love, which is systems management, IT management. But there are some papers and some research of using promise theory for economic and game theory. So it is relevant to other cases. There's some papers about it in organizational behavior. And last year at DevOps Day about in Silicon Valley, I had a professor from California, Santa Cruz, told me that he was trying to apply promise theory to the quantified self movement. So if you've heard of the quantified self movement, and I'm not going to go over that now, Google it, and you look at promise theory, and the reason he said why it's really interesting is there's a lot of complex systems out there, but the beauty of promise theory is it actually has 10 years of burn time. And it's actually been proven out on computers, which are much easier to do than to prove out on humans. Right? So he thought it might be an interesting model for things other than computer systems. So at the core of promise theory is this kind of contrast between an obligation and cooperation. Right? And it ties back between kind of facts and probability. Right? You start thinking of things like the idea of failure. You move from kind of an obligation way of thinking is like, it must never fail. I did this DevOps workshop a couple of years, a large telco. And I remember this guy telling me that, in order to put a change in production at this telco, you must guarantee that it never, ever, ever, and he went on for like 15 minutes with his evers, fail. And I said, dude, that will never, ever, ever, ever 15 minutes, not really, happen. Because guess what? Failure happens, right? That's a core of DevOps, right? So it will fail. Things fail on airplanes all the time. You don't see them because they cooperate as autonomous agents fixing things. Automation, it must look like this. Those 1,000 servers, I'm going to cast my spell. I mean, I like Chef a lot, all right? But I'm going to take my recipes, and I'm going to cast my spell on you, and you will look like this forever and ever. And even if you don't reply, in an hour from now, I'll figure out that you didn't look the way you did. All right? Get it? Or you know what? How about, can you just tell me that you're probably going to look like this, and I'll make the assumption that you're going to look like that, and I'll basically deal with the contingencies. Right? And visualization, another example, tell me how it looks. I am a monitor, and I must know what, I always used to love the single pane of glass concept. Bank of America. They're walking me through one of their knocks upstate New York, and it's the single pane of glass. This is 10 years ago, right? They probably still have it. And it's still probably running Tivoli. And it still probably means nothing. But the point is, they would say, this is the single pane of glass. And I think the CIO got on the cover of Information Week for this. That tells us everything about Bank of America. I'm like, you guys are idiots. There's no way you're going to have a single pane of glass that's going to tell you everything. And guess what? Even if it did magically, 4 seconds later, it wouldn't reflect the way it really is, right? So kind of going into what a promise is. So if you do the research on promise theory, and I think it's worth reading the research because it becomes really interesting. And if I fail miserably at opening up your mind to it, then maybe all I could ask is go read it and see. Wow, that guy was really bad at explaining it. But the point, one of the points that are made in the literature about it is we mistake the concept of a promise and an obligation. Like we think a promise and obligation are the same thing, and not really the same thing, right? Obligations again are kind of problematic. They're fact-based. They're making brash assumptions about things. You will look like this. No, I really won't. No, you will, right? And they oversimplify things. And I'm going to use some examples to end up here. Obligations allow you to take things for granted. Right? It's like the lazy man's out. Like everything's going to look like this. Whereas a promise becomes, I'm going to try to look like this. And guess what? Since I'm an autonomous agent and I'm promising, you better have some contingency plans if I don't. Right? It changes the way you think about it. The other thing about obligations is, if you think about it, how can I obligate? Like, I will look like this. Well, what if it's Wednesday and it's raining and a truck drives through, 4 pylons? This is a true story. Rackspace, right? Rackspace had actually one of their cloud centers in Dallas. A truck driver fell asleep. He he actually passed out. His foot on a pedal on a back farm road, got up to about 70 miles an hour and bust through 2 concrete pylons that were guaranteed to protect 50-mile-an-hour cars. Hit the 2 transformers or the 2 pods that bring in 2 different electricity things that happen to be not far enough apart from each other, and hit both of them. The data center still stayed up. And when the EMTs got there, of course, and by the way, the guy was still alive, the truck driver. So, of course, they shut down the power, even though they didn't fail. And they were down for like 6 hours. And it was 2.5 years ago, it was Rackspace's big, announced, oh my God, the cloud is dead, it doesn't work story, right? So you can't guarantee life, right? So if I deconstruct a promise, get a little more detail here. I promise you I won't get into math, and I'm not that smart. If you are, read the paper. The idea is you have agents, and basically, there must be an agent in order to make a promise. An intention is made, and I'll give some examples as a description of the behavior that you're going to. And there's a distinction between an intention and a promise, and I'll cover that in a second. And then it has a body. And again, the other thing that if I haven't pointed out, there is gory algebra and atomic theory that backs all this up, right? So this isn't just like some DSL that somebody wrote and said, oh, by the way, do this. But the body explains the attention. There's a concept of a quality and a quantity. And so let's take a little bit of an example and map that to kind of the promise. I will feed your cat. You're my neighbor. You asked me to feed your cat. I decide, because you basically have got a new job that on Mondays and Fridays you have to go in to the office. And, and so I'm going to promise on Monday mornings and Friday mornings I'm going to go over there in the morning. I'm going to wake up, get out of bed, and feed your friggin' cat. And the promisee is my neighbor, and the promiser is me. And the notation for a promise is a promise, like in this example, the promise B from agent 1 to agent 2, right? So there's this notion of a scope of a promise, right? So I said earlier that an intention turns into a promise once you scope it. In other words, if I am an agent and I have a promise and I haven't documented that or broadcasted it to some other agent, then it's an intention. Once it's been broadcast and documented, it becomes now a promise to somebody. Like, for example, if you think of the 2 agents, me and my neighbor, my neighbor has basically created kind of a promise to me, and I've made a promise to him. I promised that I would feed his cat. He's promised that he'd basically allow me to get in there into his house in the morning. Right, so we kind of used, if you look at the promise theory, it uses this syntax of describing promises. And so if you look at the example of me and my neighbor, it's a 2-way promise. I promise that I'll get up on Monday and Friday and feed his cat. He promises that the code that he gives me for the alarm works. I'm not going to get arrested because if I hit the wrong number, there's a level of trust, which is an important discussion as part of this, right? Trust, this whole thing works. It goes back to the cooperation model. There's a trust layer that I won't go in there and drink his 25-year-old scotch, right? Or I won't trash his house. I trust that if I make the effort to get up in the morning, roll out of bed, I'm not a person, that, he'll make it, he's going to accept the fact that there's going to be a vehicle for me to get in his house, and there's going to be food for the cat. There's economics behind it. The fact that, he might pay me for it. He might actually make more money. Or maybe I just want to be a good neighbor, and I know I'm going to need his help in the future. Right? All these things become part of the cooperation model as part of the obligation. Right? Because if my neighbor, 2 horses down from me, tells me, hey, you, idiot, come up, feed my cat every Monday and Friday, what am I going to say? Fuck you, right? So let's take this to kind of a DNS example. We'll wind it up. So So DNS basically, if you think about in promise theory from DNS, right? There's this idea that that we have a client and a server, and the DNS server promises that if I go ahead and ask it a question, it's going to go ahead and give me some information, right? Simple. But really, what happens is if I start decomposing this, right? I realize that there's two agents in this request. There's a client and there's a server agent, and it's really a two-way request, right? In that, just like my neighbor and me, the DNS server is promising me that if I ask it a question, that it will basically respond to me. So, in other words, he has two obligations. One is not obligations, so a bad word. Two acceptance promises that basically he's going to accept my requests, and then he's going to go ahead and return my requests. Right? All right, not a big deal, right? No math, no science. But what gets more interesting is if you break this down into kind of a browser resolver server scenario, we see that things that we take for granted, like a DNS better work, right, really becomes, if we start decomposing it from thinking in terms of autonomous agents, where we start seeing this like, we start removing a lot of assumptions, right? And I think that's the point I want to make as I read this is that, like, if we look at it like, hey, I'm going to hit the browser and DNS better work, and that's how I build kind of my SLAs and all that stuff, as opposed to looking at it in a model where I've decomposed it and I said, you know what, the promise that the resolver gives is basically to, very much like the client DNS, is to basically accept and respond. But the truth of the matter is, then you have the promise from the DNS from the resolver, right? Which means really there isn't really, in other words, promises aren't transient. And so in other words, to really decompose this, we're almost done, so I'm even going to figure that out. There's more promises involved, and that is that the resolver actually has to make 4 promises, in that not only is it going to reply and accept, but it's also going to promise to forward and then also accept from the DNS server. And again, the point here is what it forces you to do is stop thinking in generic terms, in fact-based thinking, in overall global everything will work, to thinking autonomously, and I can only control what I know about. So it's kind of arrogant to basically think I can control things I can't control anyway. So I go with this idea that things will fail. I start thinking from kind of bottom up, and I start composing things. And so kind of last but not least, I think some key points that I've made. One of the strengths of this way of thinking is it doesn't let you take things for granted. It forces you to inspect those decision points and define for failure, right? As you start decomposing things you see, and you start thinking autonomously, and you start thinking about, like, I can't promise or I can't obligate things to do that I have no control of. It allows us better to see how things work. They really work. It allows us to set the expectation for behavior. Instead of just thinking, just looking at the bigger picture, and then it creates a chain of responsibility. Anyway, that's what I've taken away. There's a lot more math to it. To tie it all together, again, I think that there's a lot of, excuse the pun, promise in indeterministic thinking. I think that at DevOps at the core, I think there's a connection point between complexity and complex adaptive systems and a lot of stuff we're doing. These are some of the books that I've basically read over the last couple of years that has shaped my thinking, whether I'm crazy or not. Starting with Stewart with control charts, where he spends a lot of time trying to understand variation and what variation means, which becomes very important for Deming, very important for Toyotono, Lean. If any of you have heard of Lean Startup, Eric Ries, right? It is now becoming the de facto model for almost every startup today, right? There's, universities now teach classes about it. Eric Ries was a DevOps guy, sorta. He basically took a lot of the ideas from this book called Four Steps to Epiphany. He combined that with Lean. He was a student of Lean in manufacturing. Really interesting book. This book I've just read, The End of Certainty, is really what codifies. It's a book of all the stuff that I've been thinking, hey, maybe I'm just an idiot. This really brilliant guy basically wrote a book that basically drives this whole story of indeterministic thinking and how determinism is dead. And then Gene Kibb's The Phoenix Project, which is an awesome book. I would definitely recommend. You'll love it. It's written for people like us. And then finally, hopefully sometime this year, the DevOps Cookbook will be out. I'll put this up on SlideShare on the Botch Gloop. Here's some of the detailed references. I hope I started your day off with a way to think about things. If I didn't, I apologize. Thank you very much.
So officially we're in a break till 11:30, but I think there's some interesting stuff here, and if anybody wants to hang out for some Q&A, we can do that really quick. Does anybody have any questions for John?
I was just wondering about implications of promise theory with security, maybe applying signatures to promises, that sort of thing.
Sorry.
So the question was, could it apply to security? And I think the answer is yes. I think, what I think is most fascinating about promise theory is that I would love to see more momentum of people trying to drive it, because right now, as it sits, it is the most promising framework for, kind of quantum computing, really, at our level. Right? Whereas, it's something that we can grasp and try and get maybe to work today. Right? So.
You had a question?
So how bad is the complexity explosion when you have agents that can't directly communicate? So how bad is the complexity explosion when you have agents that can't directly communicate?
Okay, he said, how bad? Is the complexity explosion when the agents can't communicate?
Yeah, I mean that's at the core, and yeah, it's a butterfly effect, right? And and that's the core of why, like deterministic models or obligation models are starting to become more complex to deal with, right? And that it seems like the only way to deal with this is based on probability, and in that that if I can't connect it to n number of agents, I'm going to have to make a decision based on trust, what I know, and deal with it, right? Because the alternative is silly, right? To try to presuppose something, right? So I think that's the core of why I think promise theory, it's not even a pun anymore, is promising, because it maps so closely to what other areas of science are doing. Probability, statistics, working in cooperative models. And again, I'm not an expert on aviation, but again, it's not hard to look at that model to say, when, we don't see. So after that Air France disaster, right, which was started, I remember the Air France that went down, right? So that actually started with what they call those little gauges that detect the speed, the airspeed, and they all froze. And this whole cascading thing of events happened. It came out to be this unbelievable story of complexity. There's some great write-ups on it about how complex systems fail. And so one of my neighbors actually flies the Atlanta to Pittsburgh route, and I talked to him about that, and he says, you know what, John? That shit happens all the time, right? So that one disaster that cascaded into all the possible commutations that became like this critical mass of failure. Like he was saying, you don't know how many times I'm flying across the Atlantic Ocean, and I have to deal with those valves all freezing. And the point is, 999, ridiculous amount of times, all those things happen, and they're self-corrected and they work, right? But the idea that he could sit there and manage that himself, and so my only point is, probably I'll be dead by the time all this shit happens. But in IT, it seems inevitable that we have to figure out a way to operate the way other areas of science behave. And if you listen to John, which I know you do, right? He thinks a lot about this from how we run operational infrastructure and complex adaptive systems. So, yeah.
John, pointing out how many idiots we are. I appreciated that. I'm one of those people who's not using config management. Part of the reason is that I am trying to deploy at scale. I work for HP Cloud, and we're trying to solve the entropy problem. And I'm curious if you see what you're working on, or what you're talking about, rather, with promise theory as more than just a way to deal with entropy. Because I see that it's basically, when entropy happens, what will you promise to do? And if you can eliminate entropy and as much as possible, does promise theory is it still relevant, or do we still need as much if we can just eliminate entropy?
And probably argue this incorrectly, and not being a scientist, I would argue that entropy is inevitable in the world that we live in, and that promise theory is a way to possibly deal with disorder, right? As things get so complex and so hard, and just disorder becomes part of the way we do infrastructure. Which again, my Facebook story, right? Where Kato Pirani said, we've already had to address this. It's impossible to think that humans could basically do remediation, from a human controlling model. Yeah. Yeah. And I need to look more at that. Again, I don't. It'd be interesting. Yes, we want to create order, and I think we're going to live in a world for the next 5-10 years where controlling order is going to be the theme of the day, right? But I think there will become a point, and there are already companies at that point where entropy. Maybe the new shirt is entropy. Deal with it. So promise theory. Or certainly, I can't promise you that promise theory is the answer. What I do know, I will unapologetically say, is I'm pretty certain that complex adaptive systems and complex systems are the only way we're going to be able to manage these systems.
Hey, thank you very much, John. So we're in our break.